Hi everyone, welcome to This Week in Space Science. I'm Michael Baltimore. I'm here with Dr. Sean Cruzen. Sean, how are you today?
I'm good, Michael, thank you.
We're going to talk about everything space science, but today it's a very interesting show because we're going to talk about the sun. You know, it's this time of year, it's very cold outside.
It is cold outside.
In Georgia, so we've just wondering where all this cold is, how long it's going to last, and so forth. So it may have some implications for some of the questions and things we talk about a little bit later on.
It's been quite unusually cold here in Georgia, by the way.
Unusually cold.
Unusual.
I had a friend of mine say the other day that, look, all this polar cold air is coming from the polar caps, and their glaciers are melting, but all this cold air is coming here, and that was his theory. And I thought, okay, I don't know enough about that to believe that or confirm it one way or another.
Well, there is
been cold weather, but we've had ice ages here on planet Earth.
We have.
So I'm beginning to wonder, and you are going to tell us today about the sun and what's going on. Just in the recent past, last few days, we've had some major events on the sun. So start us out. Tell us about the sun and what's going on.
You know, the sun is such a fascinating machine because what the sun is, it's a fully unregulated nuclear power plant that's just running away out there at a very constant and even rate of nuclear fusion, which provides us with a very constant and even rate of flow of energy coming from the sun. And it was literally the power plant that drives all of the life processes that take place on the surface of the Earth. So that seems important, right? And it really is important. So we like to think that that sun has a behavior that is very, very constant all the time. But there's actually been one part of the sun's behavior that we've known about for quite a while that is not constant, and that is this whole business of a sunspot cycle. So once in a while, the sun just breaks out in spots, and it seems to peak about every 11 years or so. And here we're seeing a couple of images of some sunspots that are on the sun today. And just to give you an idea, as you look at that, there's a close-up on the right-hand side and a full disk image of the sun on the left-hand side. The full disk image on the left-hand side shows the whole disk of the sun. You can see those sunspots are reasonably large compared to that disk. You could line up the Earth 109 times across that disk, which means those brown spots you're seeing up there, they're larger than the Earth. In fact, we got a close-up of two of those big storms on the bottom right-hand side right there. That happens to be three different sunspot groups, and we number these sunspot groups. It's 1967, 1968, and 1969, and those are not greatest hits years for the Beatles or something. Those are the number of sunspots in this particular sunspot cycle, because you see, the sun breaks out in these sunspots every 11 years or so, and then it goes quiet again where we don't see these sunspots, and then the sunspots come back again. And that is what is at the heart of this thing that we call the sunspot cycle. Now, these recent sunspots right here, they're twists in the magnetic field of the sun. They're dark because they're a little bit cool by comparison. Certainly they're not cold. No. It's on the surface of the sun after all. But they're cool compared to the rest of the surface of the sun. And so they are caused by twists or contortions in the magnetic field of the sun, which suppresses the convection. In other words, it causes that heat not to flow up from the interior of the sun quite as evenly. And right there where those sunspots occur, the magnetic field stops that compression and it cools off. And that's why we get these dark areas right there. Those sunspot groups, again, about Jupiter size right there, if the magnetic fields become too bent and warped, they can explode. And that actually happened about 3 days ago. And we can show you this image right here. This is an image taken in a different wavelength of light, which is it's in short wavelength ultraviolet, and it shows very clearly a big white spot right there in the center of the sun. Now, this unusual view of the sun, everything that's white is intensely hot. In fact, that white area is probably about 1.5 million degrees Kelvin in temperature right there. Wow. That was a solar flare occurring. So the solar flares are giant explosions caused by the magnetic warping and actually magnetic fields breaking on the surface of the sun, and it can release tremendous amounts of energy and you get a solar flare. Now, these solar flares can eject material toward the Earth. And when we talk about material, we're talking about stuff that's off the surface of the sun. Well, you may not know what the sun's made out of. So the sun's mostly hydrogen. Hydrogen's the simplest atom. It's got a proton and an electron. Sometimes it has a neutron. But protons and electrons, and then the other element that the sun is mostly made out of, which is helium, has a couple of protons and maybe a couple of neutrons with some electrons attached. Anyway, that is the kind of material that gets blasted out from the surface of the sun. Now, when that stuff is moving through the solar system, it's away from the sun, we call that free flow of these subatomic particles, we call that radiation. So these are particle radiations that are moving from the sun toward the Earth. And if you get in a stream of these helium nuclei, which we have another word for it called alpha particles, if you get in a stream of those, you have a lot of those interacting with your body, you're being irradiated by radiation. And so this is actually can be deadly material that's flowing out, millions of tons of it flowing out from the sun during one of these giant explosions. And so that stuff can actually flow into the Earth and cause some things to happen right here on the surface of the Earth.
A lot of things to happen on that. Sean, let me ask you a question. The sunspots that we saw in the very first picture James put up there, those are cool zones. Those are not considered explosions.
Yeah, they are not themselves explosions. It's, you know, the way I like to think about it and really simplify the wording down is, imagine this. Imagine if you took a beach ball and you held a beach ball under the surface of a swimming pool. You can do that for a while, but that beach ball wants to pop up somewhere, right? So those sunspots and those bent magnetic fields, they're holding down a lot of heat energy trying to flow up to the surface of the sun. And so that's what's happening. So you have the bent magnetic field holding down energy, and right there where the energy is being held down, it cools off. So you're seeing that brown spot right there because that surface is cooling off, the heat's being held down. But that energy likes to get up somewhere else. And so you'll oftentimes find bright regions around the outside of these sunspot groups.
Okay.
Well, if the magnetic fields that are holding down that energy suddenly break, they can release a tremendous amount of energy all at once. That'd be like holding the ball underwater and then letting it go and it pops up out of the air, right? So all that energy can actually blast out a whole lot of material from those sunspot groups. So when the sunspot group changes, or the magnetic field that is responsible for the sunspot group changes rapidly, it can result in a big explosion. So you're right. The sunspots are like storms, but they're not like tornadoes. Right? So we think about a thunderstorm. Not all thunderstorms produce tornadoes, but they can. Not all sunspot groups produce flares, but they can. So the flare is like that rare, violent event that can occur from one of these big storms on the surface of the sun.
Okay, so you also said these sunspots and flares have a cycle.
They do. They do, and again, it peaks. That cycle peaks about every 11 years. We're right now near the peak of solar maximum, and I say that in a kind of an incredulous tone because you saw some sunspots right there. It looks like we're at solar max. There are big sunspots on the sun right now. Well, it turns out that this solar maximum has been the quietest solar maximum in 100 years. So even though we're at an increase in the number of overall sunspots on the sun, that number compared with cycles that have occurred in previous decades is much, much lower. So this is a very quiet solar maximum. Something is changing on the surface of the sun. These kinds of changes have occurred in the past, and there are some ideas that they may have been responsible, or at least correlated, to variations in the climate on Earth, also in the past. Now, when you start to talk like that, you start to move into this whole, oh my gosh, science fiction, the world's going to end kind of language. And I want to be very careful here. Okay. And I want to note that this is just an idea that's being floated out here, but it's an idea that's at least worth looking at. All right? So if we could pull up a graph, there's a graph of the current sunspot maximum compared with the last sunspot maximum. And what you're going to see is, oh, I forgot it. I'm sorry, I forgot about these. Let's show these first because this is important.
All right, I got it.
So this is happening right now. We talked about a large wave of material coming in and interacting with the Earth. How do these waves of particles interact with the Earth? Well, they hit the Earth's magnetic field and they cause the air to glow over the north and south poles because that's where Earth's magnetic field is more intense. So what you're seeing right here is a ring of glowing light. We call that the auroral oval. This is actually kind of just a map, actually, made from sensors. But that's where you will see northern lights occurring, is in that ring where that charged radiation from the sun is interacting with Earth's magnetic field. Let's go ahead and go to the next picture here. I want to show you this one. These are actually northern lights taken in Anchorage, Alaska. A photographer by the name of Mark Lester from the Anchorage Daily News captured these images right here, and we're seeing northern lights. So this occurrence, the aurora borealis, northern lights, is triggered when radiation ejected from the sun comes in contact with the air of the Earth after being funneled in by the Earth's magnetic field toward the Earth's poles, North Pole and South Pole.
Nice explanation, by the way, and I appreciate that very much. Sometimes we don't get to the science of what those wonderful, nice, and pretty lights look like.
That's exactly right.
The science of it, so thanks for that.
Yeah, you're welcome. So we like to see these. So you would expect to see nice auroral displays like this one at the peak of what we call solar max. And you know, so we're comfortable with seeing these as long as we know solar max is going on, because we expect a lot of sunspots on the sun, which then produce big flares, which then shoot this material towards Earth, and we see lots of nice aurora in the nighttime sky near the poles, North Pole and South Pole of the Earth. Occasionally, if it's really a violent storm, you get these northern lights moving down into the continental United States, and people in the US can see these phenomenon as well. So that's a normal sunspot cycle. But in the past, we have seen evidence that sunspot cycles are not always the same. And so right here, this is it's an image of the sun in the background, but in the foreground, you're going to see a white plot. On the left-hand side was the last solar maximum. The last solar maximum, this is a plot of sunspot numbers. On the right-hand side is the current solar maximum. You're going to see that the number of sunspots occurring right now is much, much lower and is leading toward a much smaller solar maximum than we saw the last time this occurred in about 2002, 2003, when solar max occurred last time. It turns out that that solar maximum, the previous one, was not even as strong as the one before that. So what we're seeing is a series of decreasing solar maxima. And this suggests some kind of strange change that's taking place on the sun. Now, it could be an underlying cycle. So what we want to do is we want to look back and see what the sunspot cycles have been like for a number of years.
This is going back in time. You've got 1749.
Exactly.
2040. This is a long map.
So we're looking back in time about 150 years here, right? So, 250 years rather, 250 years. We're looking back in time a good number of years so that we can see what the sunspot cycle numbers have done in the past. And so it turns out, since telescopes have been good enough, human beings have been capturing images of the sun and being able to count these sunspots. So we have data that goes back to, actually, to the late 1600s about these particular sunspot activities. Notice on the three peaks on the right-hand side, you're going to see a number 23, 24, and 25. The last solar maximum cycle was cycle max number 23. We're currently in sunspot cycle number 24, and it's about halfway done because we're on the peak of that. So from the right-hand side of that over is the projected sunspot cycle by scientists who study activity on the sun. If you notice what they're predicting for cycle number 25, it's a little tiny bump.
It's a bump, that's all. And look at those peaks on the other. There's even something on this map that says modern warm period, where those very hot, tall spikes are. And at the very last, we're at 25, which is you called it, a bump.
Exactly. So you're seeing that on that graph, the modern warm period defined during a time when the sun had its most active solar maxima. In other words, it had its cycles where it produced the most sunspots. And if you look back there at about 1799 on that graph, to the left-hand side, you're going to see something called the Dalton minimum. And the Dalton minimum occurred during a time when the Earth was a lot colder than it is normally.
Okay.
And so this is something called the ending portion of what's known as the Little Ice Age. And you see the official total end of the Little Ice Age happening in about 1899 or about 1900 right there. But there was a period of time before that even when things on the surface of the Earth were even colder. And I think we have one more graph here. So if we look back even farther in time, and mind you, the data gets a little sketchy prior to 1750. But that's partly because the sun itself was not producing as many sunspots. And so Galileo he used a telescope to start observing the sun in the early 1600s. And he started keeping records of what the sunspots were doing back in the very early 1600s. And notice that by those early record keepings, there were some solar maxima that were very energetic. You see those in the red dots. There were other solar maximum that were fairly energetic in the mid to late 1700s. But right there between a period of time of about 1650 and 1715, there were almost no sunspots appearing, and there were almost no solar maxima occurring. This time also correlated to a distinct lack in that aurora phenomenon. In other words, history does not record very many appearances of the northern lights, which would tell us that there probably wasn't as many solar flares taking place.
Okay.
Something bizarre was taking place on the sun. Now, what was happening at the Earth during that particular time? Well, on the surface of the Earth, there was something going on called the Little Ice Age. And this is literally a period of time where there were almost no summers in important parts of the Northern Hemisphere like Europe. And so there were periods of time where winter just didn't seem to end for many years. This caused all kinds of famines to take place because crops failed. There were wars that occurred because of the Little Ice Age. And so this was a very dark period in time because of some kind of climatic change, some kind of climatic difference on the surface of the Earth. The big question is, were those two things tied?
Right.
We don't know. Scientists are still trying to determine if there was a correlation between what was taking place on the sun, that Maunder minimum, and what was taking place on the surface of the Earth, which was the Little Ice Age. It turns out there could be a correlation, which is why scientists are looking into this. Now, let's just extrapolate for a moment. Okay,
Sure.
If there's a correlation between Earth's climate to the level that we're going to have giant variations in the surface temperature on the Earth and what takes place on the sun because of the sunspot cycle weakening, and we actually see a period of time right now where it appears that the sunspot cycle is weakening, well, that might mean that we're in for interesting times.
I know what you're about to say. We're about to creep in to this new ice age. I'm not a fan of the ice age. Let me just make my position clear.
I like that little scrat guy with the nut. I mean, I like him. He's always trying.
Yeah,
Ice Age.
the ice age guy. Yeah, that's.
It makes me smile. I'm not sure I'd want to live through that particular period, though.
No, I don't think so. I mean, I think you brought in a painting or a drawing here. Let's take a look at oh yeah, there it is.
So this is
That's
a painting.
about it.
It's a painting done by an artist named Bruegel, and it was done in 1565, which would have been just at the beginning of that Little Ice Age period of time. This was representative of what was taking place in Europe at the time, because winters just seemed to last a very long time, and summers were particularly short. The winters were particularly harsh. You will notice, of course, that civilization did seem to continue through this particular period of time.
We still have houses. We're out ice skating. The dogs are okay. People have clothing. Okay, we survived that.
Somehow humanity survived that period of time, but it was not comfortable for many of the reasons that we talked about. And if you look into the history of the Little Ice Age, you will see there was a lot of turmoil in a lot of the world's populations because of these climatic changes on the surface of the Earth. Now, let me emphasize again that I'm not sitting here saying the world's going to end, we're all going to freeze, and we're going to have a famine. I'm not saying any of that. I'm just saying that the sun seems to be going through an unusual period of time. And it's not just me that's saying that. So there's a scientist, an astronomer by the name of Mark Giampapa. He's with the National Solar Observatory. And Mark Giampapa has cited a few things that he notices in data being taken from the sun. The first of those is that diminishing number of sunspots. So there's a definite decrease in the number of sunspots happening on the surface of the sun. You saw the graphs for that just moments ago. But in addition to that, those magnetic fields that are associated with the sunspot groups themselves tend to be, on average, weaker right now during this particular solar maximum than they have been in the past. So in other words, there's not as much magnetic field strength associated with this current batch of sunspots than there has been in the past with previous batches of sunspots in previous solar maxima. That's unusual and is another indication that we might be seeing a decline in the sunspot activity on the sun, even over multiple cycles. The third thing he cites is just the overall weakening of the polar magnetic fields on the sun. So the difference between the magnetic field of North Pole and South Pole, the difference in intensity of that magnetic field is just not as great right now as it has been during other periods of the sun's magnetic field. Because here's what happens. after solar maximum occurs, after you get that maximum number of sunspots, the sun's magnetic field actually changes polarity. I'm not talking about the sun flipping over, but the field changes from north to south and south back to north over a couple of sunspot cycles. Well, the strength of that field is what has been noticed to be diminishing. The fourth thing is they watch what they call subsurface flows. This is flow of charge. You can think of it almost like rivers of electric current beneath the surface of the sun. They can track those using magnetic fields and track how these subsurface flows are moving through the interior of the sun. Those have been weaker as well. So these rivers of electric current flowing in the interior of the sun have also decreased in intensity. This is multiple signs that something unusual is taking place on the sun. Now, certainly, climate scientists, solar scientists, they're going to be watching this situation very, very carefully. But I thought I would come on because we still do have some sunspots occurring on the sun right now. But this report just came out from the folks at the National Solar Observatory talking about how unusual this is, and with that kind of rather frightening prediction of what this next sunspot cycle might look like based on what we're seeing now, that might lead to one of these phenomena that they call a grand minimum, a period where the number of sunspots is very weak and you get changes on the sun. Will that affect the sun's energy output? Will that affect the Earth's climate? We just don't know right now. Certainly a topic that's worthy of being studied in the coming years.
Oh, absolutely. We need to watch that because now I'm beginning to be a fan of sunspots and not of the ice age. Just again, make my position clear around that. But
yeah.
All right, something we need to watch. It's very interesting. And again, you said at the outset, this is a correlation too.
Yeah.
There's not cause and effect, but as we gather more information, we'll know.
Yeah, and you know, these kinds of things occur in science where you can have simultaneous events that would on the surface look as if they're correlated, but then really have no physical connection whatsoever. And particularly when we're looking back through historic records or the geological record or records of time in memoriam that we have to kind of extrapolate together from secondhand data, which both of these things really are, then it's hard to really pin down and correlate whether those things really are correlated or whether they just occurred in history in a simultaneous fashion. But if the sunspot cycle really does weaken the sun's overall energy output, we're going to see in real time, you know, whether that's true. And so Mark Giampapa and the folks from NSO, National Solar Observatory, have made a prediction that if that's going to occur, the next grand minimum might yield a minimum activity cycle all the way up through the year 2080. Now we're in 2014 right now. So all the way up through 2080, another 66 years of sort of minimum solar output. So again, that's the models that are being proposed right now. It's not a clear-cut for sure thing that's going to happen, but it is interesting and it bears out watching, and that's why we do science, is so we can kind of use past events to predict some sort of future behavior.
All right, we need to mark this show. I think our TV crew will mark this one. We need to come back and check this out. Is this bad?
I'll be happy to come back in 2080 and we can talk about it again if
we'll
you
leave
like.
this in our archives, and maybe somebody will dig this up. Ladies and gentlemen, thank you for watching This Week in Space Science TWISS. You've been watching Dr. Sean Cruzen from the Coca-Cola Space Science Center here at Columbus State University in Columbus, Georgia, and you're watching CSU, Columbus State Television. We'd like you to tune in each week for This Week in Space Science. We'll see you next time.